Okay, so the first topic that we have to start with is gradient descent. And this is essentially, it requires a bit of calculus knowledge, but gradient descent is kind of the main algorithm that actually updates a model's weights, and it actually is, how the model learns and how it trains, I guess. So I guess the starting point is, first of all, let's say we have a model, and we give it an input, and then we get the model's predicted output, right? The input along with it, whether it's supervised or unsupervised, but there is some form of like labeled data, or we know the required data that which we can then compare with the output, right? So we give the model an input, we get the model's output, and so we calculate the difference between the model's the model's like predicted output versus like the actual, I guess maybe not labeled, but like it is labeled, right, with the input, but we get the model's output versus like the actual, and this is essentially our model's error. And so in machine learning, we basically have this idea of like an error function, which is just, I guess, how the outputs of the model, like the errors of the outputs of the model given varying inputs, right? And so the idea of gradient descent is we want to minimize this error. So basically, if we minimize this error, that will basically make our model more accurate, right? And how we minimize this error is we basically, let's say we have this error function. Let's say it's y equals x squared. Then we know the derivative of that is just 2x, and we know this is minimized at its local minimum, which is just at x equals 0, right? And so at that point, that is when essentially when the weights have been fully updated, like, and there's no more error, right? And so and when you're learning gradient descent, you can think of it like you are on top of a hill, and you're trying to get down the hill. This is you as a person. You're trying to get down the hill. We can treat this as three-dimensional, but you're trying to get down the hill, as fast as possible and as efficient as possible. And so gradient descent is basically composed of it's like the steepest path down a hill. Like, for example, if it's like a hill of air, right? And so the path will be marked by your like the change in your error function. So your d error, and then like the actual step is this other term which we call alpha, which is your learning rate. Which is your learning rate. And so gradient descent is just the idea of your new weight updating weights, right? So the model has these parameters called weights, which basically, tell you which parameters to emphasize more. So then the model knows, like, given a specific input, they can predict an output. So we update the weights by saying the weight new is basically the weight old minus our learning rate alpha, so the size of the step times the error, right? So times like our error function, right? So essentially, learning rate is always fixed, and so every single iteration, we're basically calculating the error function, we're calculating the derivative of it, and then we're using that and we're updating the weights. So then every iteration of the model, like every iteration of it, we're going to update the weights, and we do this until we've updated the weights, and we say, okay, the model's it's learned a lot, the parameters are pretty good now, it's good at predicting, it's got a good predictive output, right? And now I want to go into and now I want to explain, I guess, the equation. Like, why are we subtracting alpha times that, derivative of the error, right? So let's go back to y equals x squared. We have our our curve, our parabolic curve, y equals x squared, right? And so let's say at this positive value, let's say, x equals 2, the derivative at that point, obviously this is a 2D graph, but the derivative at that point is just, it's increasing, right? And we know that the minimum is at x equals 0. So the minimum is to the left of it, and we know that it's increasing. Therefore, we want to subtract in order to get closer to 0. On the other hand, if we are to the left of the minimum, and we are actually decreasing, and we need to go to the right, right? So we're at a negative number, but we want to turn that negative number into, well, we want to make it 0. And so how do we do that? We have to subtract it out. So that's why we have to, that's, I guess, the key idea behind the minus sign. But yeah, gradient descent is our algorithm for training the model parameters or weights.